All right, in this section today, we're going to look at solving trinomials that have a coefficient that is not 1 for the leading coefficient. For instance, if we had 2x squared plus 5x plus 3, and I want to factor this. Well, it's really very much the same way that we did before, because before we had a leading coefficient of 1. So what we're going to do is take the leading coefficient in the last term, and we're going to multiply those two together. We get 6, and both of these terms are positive. So we're going to look for factors of 6 that when I add them together, they give me 5. And hopefully you can see very quickly that that's going to be 2 and 3. So what I'm going to do now is write that out as 2x squared plus 2x plus 3x plus 3. Notice I put the 2x first because I had a 2x squared starting, and so they have a common factor. Now what I'm going to do is group, let me change this color, we're going to group these two and these two, and I'm going to factor out what's common in each of those. So for the first binomial, I have a 2x common. And if I factor that out, I'm left with x plus 1. In the second, I have a 3 common, so I'm going to factor out a 3, and I'm left with x plus 1. And notice we've done this before. This is common to both terms. So I have x plus 1, and I'm left with 2x plus 3. And we've just factored that. In a lot of ways, it's just like what we did before, except this time we are multiplying that last term by whatever's in front of the x squared. Before, we always multiplied it by 1. So we're going to work through several of these so you can get some practice looking at how these work. Let's look at another. Let's do 5x squared plus 13x plus 6. Now what I want to look first is make sure that there's nothing common to all three terms that I could factor out. And in this case, there's not. So I'm going to multiply 5 times 6, and we get 30. So I'm looking at factors of 30 that when I add them together, give me 13. They're all plus, so I don't have to worry about plus or minus. So we know that 1 and 30 is too much. 2 and 15 doesn't give us 13, but 3 and 10 give us 13. So I'm going to write them down, 5x squared. Now I want to write down the term that has something common with 5x squared, and that's going to be plus 10x. And then we have plus 3x. That gives me the 13 that I need right there, plus 6. Notice this stays the same and this stays the same. These two middle terms have to add up to the middle term of the trinomial. Now I'm going to factor out, I'm going to group these two and these two, and I'm going to factor out what's common in each term. So here we have a 5x that's common, and 5x squared divided by 5x just leaves me with 1x, and 5x goes into 10x 2 times. In the second grouping, I can factor out a 3, and I'll have 3 times x plus 2. So we get x plus 2 times 5x plus 3. And we can always check that to make sure we get what we started with. If we FOIL, we have x times 5x, x times 3, 2 times 5x, and 2 times 3, and that gives us what we started with. It's always a good idea to check to make sure you end up with what you started with after you factor. Okay, let's look at this problem. Notice I have a 6, a 22, and an 8, and 2 is common, so to make it easier to factor, I'm going to factor out that 2, and that will leave me with 3x squared plus 11x minus 4. Anytime you can factor something out, it's going to make it a little bit easier because the inside trinomial has smaller numbers to work with. So I'm going to multiply 3 times negative 4, and that gives me a negative 12. And because this is a negative 12, I know my factors, one's going to be positive and one's negative. And the larger is going to be positive because I have a plus 11x. So we can see that 12 times negative 1, if I add them together, give me an 11. So the 2 doesn't go away. I'm going to have 3x squared. And between 12 and 1, there's nothing common. Well, we could go ahead and put plus 12x because 3 goes into 12. Then minus x minus 4. Okay, I'm going to group these 2 and these 2. So let me get a different color here so we can see the grouping. All right, so I'm going to take out a 3x, and let me change that to a bracket. And I'll have x plus 4. Now, in the second binomial, I'm going to take out a negative 1. And that leaves me with x plus 4. Because if I multiply negative 1 times x, I get negative x. And negative 1 times 4 gives me a negative 4. These should always be the same. So we're going to have 2 times x plus 4 times 3x minus 1. And we have that completely factored. We'll do another one like this. Okay, here I have 10y squared minus 35y plus 30. Notice 5 goes into each of those coefficients, so I'm going to factor that out, which will make it easier to factor the trinomial. So we have 2y squared minus 7y plus 6. Because the middle term's negative and the last term's positive, both of those inside factors are going to be negative, but 2 times 6 gives me 12. And I need factors of 12, both being negative, that when I add them together would give me a negative 7. Well, we know that 2 and 6 gives me 8. 3 and 4, a negative 3 and a negative 4, do give me negative 7. So don't forget to put your 5. The first term stays the same. And I'm going to put the minus 4y first because there's a common factor here. Minus 3y plus 6. All right? Negative 4 minus 3 gives me negative 7. So let's group these 2 and these 2. So don't forget your 5. I'm going to factor out a 2y in the first pair. And I'll have a y minus 2. In the second grouping, notice it's minus 3y plus 6. I'm going to factor out a negative 3 because we really have this whole thing grouped. And so what happens is I'm going to get negative 3y divided by negative 3 gives me a y. And 6 divided by negative 3 gives me a minus 2. See, these should always match if you've done it correctly. So we'll have 5 times y minus 2 times 2y minus 3. And again, it doesn't matter whether we say 5 times 2y minus 3 times y minus 2 or we do it the way that I have it written. Either way is fine. Okay, let's do another one. 2n squared minus n minus 1. There's nothing common. I don't have to worry about factoring anything out. 2 times negative 1 gives me a negative 2. And factors of negative 2 that would give me a negative 1n or negative 2 and positive 1, because negative 2 plus 1 is negative 1. So we'll have 2n squared minus 2n plus n. Notice negative 2 plus 1 gives me negative 1 minus 1. Group here and here. I can factor out a 2n, and I'm left with n minus 1. Plus, there's nothing to factor out, but I have a 1 n times n minus 1. So we're going to have n minus 1 times 2n plus 1. It factors pretty easily. Now sometimes you might have what we call a prime polynomial. And a prime polynomial, this should be an n. A prime polynomial cannot be written as a product of two polynomials with integral coefficients. Right? We don't want to worry about fractional coefficients. So a prime polynomial cannot be rewritten as the product of two binomials with integral coefficients. So let's look at some examples. 4r squared minus r plus 7. So we're going to go about this the same way. We have 4 times 7, which is 28. Both factors would need to be negative to get me a positive 28. So factors of 28 are negative 1 and negative 28. Well, that doesn't give me negative 1. Negative 2 and negative 14. That does not give me a negative 1. 3 doesn't go into 28. 4 does, negative 4 and negative 7. That does not give me a negative 1. 5 doesn't go into 28, neither does 6. And if I put 7 in, we kind of flip and go backwards. So this is prime. There are no factors of 28 that when I add them together would give me a negative 1. For x squared minus 5x plus 7. Okay, let's check this. Maybe it's prime, maybe it's not. 4 times 7 is 28 again. And I've already got the factors of 28, so let's look and see if any of those would give me a negative 5. Well, negative 1 and negative 28 don't. Negative 2 and negative 14 don't. And negative 4 and negative 7 don't. So this one again is prime. That was easy since we just did factors of 28. Okay, let's look at this one. 2x squared plus 3x minus 5 equals 0. I want to solve this polynomial if it can be factored. All right, anytime you have a equals 0, that means you're going to solve for x. The previous ones didn't have equal to 0, so we just factored, but here we're going to factor and solve if it's possible. So let's look at this. We've got 2 times negative 5, which gives me a negative 10. And I want factors of negative 10 that when I add them together give me a positive 3. So the larger factor has to be positive. And hopefully you can see pretty quickly that 5 and negative 2 work. So we're going to have 2x squared. I'm going to put the minus 2x since I have 2 and a 2. Plus 5x minus 5. So we can factor out the 2x, and we will have x minus 1 plus 5 times x minus 1. Well, that's nice because we get x minus 1 times 2x plus 5 equals 0. And we've learned before that once we get it into this factored form, we can set each factor equal to 0. X is 1. Or this factor equal to 0. We subtract 5 from both sides. 2x is negative 5, and then divide by 2. So x equals negative 5 halves. So here are our two solutions. X equals 1, x equals negative 5 halves. Okay, I want to solve this polynomial. Now, in your homework, it's going to say confirm with the graphing calculator, but don't worry about that. All right, first thing I'm going to do is put everything, I have set this equal to 0, and I'll do that by subtracting 16 from both sides. So we'll have negative 3x squared plus 26x minus 16 equals 0. Now, in order to factor, the leading coefficient should be positive. So in order to do that, I'm going to multiply everything by a negative 1. You can do it on both sides. 0 times anything is 0. All right, and when I do that, I get 3x squared minus 26x plus 16 equals 0. In other words, when you multiply by negative 1, all of the signs change. Now, this is a form that we're used to, so let's multiply 3 times 16, and that's 48. Both factors have to be negative since this is a positive and this is a negative. And so if we start thinking about factors of 48, we know it's not 1 in 48 or 2 in 20, well, maybe it is 2 in 24. If we do a negative 2 and a negative 24, that gives us a negative 26. So we'll have 3x squared minus, I'm going to put the 24 because 3 goes into 24, minus 2x plus 16 equals 0. So group these two and these two. So if we factor out a 3x, we're going to have x minus 3 goes into 24 8 times. Now remember, in the second grouping, I have to factor out a negative 2. And negative 2x divided by negative 2 is just an x. 16 divided by negative 2 is a negative 8. These should always match, remember. So we have x minus 8 times 3x minus 2 equals 0. Set each factor equal to 0, and we can see here that this is going to be x equals 8. If you want to skip that x minus 8 equals 0, you can. You can see that's x equals 8. We could say here 3x equals 2. So if we divide by 3, x equals 2/3. So here are our solutions to that polynomial equation. Anytime you have an equation, you're being asked to find the values of x that would make that a true statement. All right, assignment number 16 is on page 513, and it is 2 to 28 even, and you may omit number 22. All right, thank you.